Welcome to Estimating Exponential Calculations. So, first off, read the Note to Students section at the beginning of the textbook. You should use the same calculator for practice problems and for tests and quizzes. If you use different calculators, then you may get to the test or quiz and not know how to use the calculator, or you may waste time trying to learn how to use the calculator. Time that you could have better spent looking at the chemistry and doing the work. So for this course, any calculator with the following buttons will work: a 1 over x, or x to the minus 1. And this one isn't strictly necessary even because this button down here, the next one, will work. So a y to the x button or a caret button, it's usually a caret on graphing calculators. A log button, this is a log base 10, and an ln or natural log button. Just about any graphing calculator or scientific calculator will have the buttons listed, or at least the three that we need. If you already have a calculator, I want you to pause the video and find those buttons right now. So we've already covered the rules necessary for calculations involving exponential notation. If you need to, go back and review section 1.1 or section 1.2 if you need to. Longer, more complex calculations involve using these simple rules that we've talked about in the last section, just multiple times. The challenge here is to keep track of the numbers and break the complex problem down into multiple smaller steps. So write out your steps on a piece of paper so you can keep track of where you are and where you're going. We're going to do each problem twice, using two separate methods. Method 1 is to do the coefficients and exponents separately. So we're going to do the coefficient math on the calculator because it's complex, and we're going to do exponent math in your head, not on the calculator. So let's look at an example. If we have 3.15 times 10 to the 3 times 4.0 times 10 to the minus 24 divided by 2.6 times 10 to the minus 2 times 5.5 times 10 to the negative 5, and we want to know what the answer is, this is not going to be easy for us to do all of this in our head, but we can do portions of it in our head. So first, let's split it up into coefficient math and exponent math. So let's pull out all the coefficients. So 3.15, 4.0, those are being multiplied on the top. Then we're dividing by the 2.6 times 5.5. So that is all of our coefficient math. Then we have our exponent math. We have 10 to the 3 times 10 to the minus 24 divided by 10 to the minus 2 times 10 to the minus 5. So now we're going to do each part separately. We're going to do the coefficient part, and then we're going to do the exponent part. So for the coefficient part, this is too difficult for us to do in our head, so we're going to use our calculator. Now we can use our calculator just for this portion of the problem. We're not going to use the calculator for this portion of the problem. So 3.15 times 4.0 divided by, and remember, when you're plugging this into your calculator, you need to plug in, if you're plugging this into your calculator, you need to put parentheses around the denominator there. Otherwise, your calculator will do 3.15 times 4.0 divided by 2.6, and then it will take that result and multiply by 5.5. So you can either plug it in as 3.15 times 4.0 divided by, open parentheses, 2.6 times 5.5, close parentheses, and then enter. Or you can multiply the top, so 3.15 times 4.0, that gives us 12.6. Multiply the bottom, 2.6 times 5.5, that gives us 14.3. And then divide 12.6 by 14.3. You should end up with an answer that is 0.881. Note that my preferred method is not to do this step and instead to skip that step, because if you're doing this step, then you're going to introduce additional rounding errors in your end result. So you should learn how to type something like this into your calculator without making mistakes and getting the correct answer. And this is where a graphing calculator really comes in handy, because you can go back, and if you make a mistake, if you type in 3.14, you can go back and edit the 4 and make it a 5 and figure out what the correct answer really be. If you have a scientific calculator, you usually have to start the whole calculation over from scratch. So we're going to discuss how many digits we should keep in our answers in Chapter 3, which is on significant figures. For now, we're just going to round all of our answers to 3 non-zero digits. So, which is why on the last slide we had 0.881. So the 0 is a non-zero digit, so we're not counting that. So 8, 8, and 1, those are 3. That's where we're going to stop. I think the book tells you that you're going to stop at the hundredths place. I'd like 3 non-zero digits until we get to Chapter 3, significant figures. So we've already done the coefficient math. That worked out to be 0.881. Now we need to do the exponential math. So we have 10 to the 3 times 10 to the minus 24 divided by 10 to the 2 times 10 to the minus 5. We're going to simplify the top and the bottom separately. So we have 3, 10 to the 3 times 10 to the minus 24. We add together the exponents. So positive 3 plus negative 24, that gives us negative 21. So 10 to the minus 21. The denominator has 10 to the negative 2 plus negative 5. So 10 to the minus 7. So now we have 10 to the minus 21 divided by 10 to the minus 7. Remember, for multiplication, we're adding together our exponents. For division, we subtract the denominator from the numerator. So we're subtracting negative 7 from negative 21. So we have negative 21 minus negative 7. That gives us negative 14. So our answer there is 10 to the minus 14. And that was just for the exponential portion. So now we need to combine the coefficient portion, the 0.881, with the exponential portion, the 10 to the 14. And then last, we want to write it in proper scientific notation, because this is not proper scientific notation. It's okay for exponential notation, but not scientific notation. We need to move the decimal point from here, one place to the right. So we need to make then our exponent one place smaller. So we have 8.81 times 10 to the minus 15. And again, note that this portion we have not used a calculator for. We've only used the calculator to give us those 3 digits, and that's it. All right, so that was method 1. Method 2 is to do the entire calculation on your calculator. So starting from the original problem, then we're going to enter all of the coefficients and all of the exponents into the calculator. And you may need help from your calculator manual, which you should be able to find online. Then you want to write the final answer in scientific notation. Now you might be able to change the mode on your calculator so that it always displays answers in scientific notation. Again, you're going to have to look at your calculator manual for this. If you have a graphing calculator, you usually should be able to do this. With a scientific calculator, that's generally not something that you can change. In that case, it generally defaults to fixed notation within a certain window. Generally, it's within 6 to 9 decimal places. It actually writes it out in fixed notation, and anything outside of that range it uses scientific notation for, but it depends on the calculator. Again, refer to your calculator manual. So, many calculators have a button labeled E or E or EXP, and you can use this key in place of the times button, the 1, the 0, and the caret button. I don't recommend using this notation. I definitely recommend using this button, whether it's labeled E or EE or EXP. So if you wanted to type 2 times 10 to the 3, you could either type the 2 button, and then the times button, and then the 1, and then the 0, and then the caret, and then the 3, or you could hit 2, EE, 3. So it's going to be shorter. It's going to lower the number of buttons that you have to push. It's going to be faster to put it in, and it also should prevent you from making a few mistakes if you leave out one of the buttons. So your calculator should give you the result 8.81188811119 E minus 15. You may have a few more or fewer decimal places in here, but in any case, we need to round the coefficient to 3 places, so 8.81 times 10 to the 15. Again, until we get to Chapter 3, we're going to always round to 3 decimal places. So, which method was easier? I find that the numbers on the calculator, the coefficients on the calculator, and exponents in my head to be significantly easier than typing out all of the exponents into the calculator. So whichever way you want to do it is fine with me, but I highly recommend using method 1, using this method, separating out the exponential terms and the coefficients, because after some practice, you should become significantly faster and more accurate with the first method than with the second method, where you have to type everything into the calculator. Note that method 1 also allows you to fairly quickly estimate what the answer should be without actually having to use your calculator. You should be able to estimate the coefficient math portion and get it close-ish. And you should be able to get the exponential portion exactly right using your head. Whenever you use a calculator to perform a calculation, you need to check for errors, which means that you need to do the calculation a second time using different steps. If you do exactly the same thing, you're going to end up with the same result, but that doesn't mean that you didn't make a mistake both times. So the fastest way to do this is to estimate the answer, which is again why I recommend using method 1. So let's look again at our last example. Here's our calculation again, and we want to find out the answer. So first we're going to separate the coefficients from our exponentials. So we've got our coefficient math here, our exponential math here. Now we're going to round our coefficients so that each one is just a single digit. So 3.15 becomes 3. 4.0 becomes 4. 2.6 becomes 3. 5.5 becomes 6. In this sort of thing, it doesn't really matter whether you're rounding up or rounding down, but whatever you do, just be consistent. Right? We're just looking for a rough estimate here, so as long as you don't have all of your numbers all being rounded up or all of them being rounded down, then you're going to be close. So now we want to perform the coefficient math in our head. So now we have 3 times 4 divided by 3 times 6, but we can separate this out into 3 divided by 3 times 4 divided by 6. Well, 3 over 3 is just 1, and now we have 1 times 4 over 6, which means we can ignore the 1, because anything times 1 is itself. So now we have 4 over 6. Well, 4 over 6 is the same as 2 over 3. 2 over 3 is 2/3. That's 0.6 repeating. So that's about 0.7. Now we have the result for our coefficient math, and we can perform the exponential math in our heads. But we've already done this once, so I'm going to go through it fairly quickly. We ended up with 10 to the minus 14. So we want to combine our results. 0.7 times 10 to the minus 14. When we write it in proper scientific notation, that's 7 times 10 to the minus 15. And that's pretty close. 7 times 10 to the minus 15 is pretty close to the 8.81 times 10 to the minus 15 that we had. So we should be right. So again, that our estimated result, 7 times 10 to the minus 15, is close to the calculated result, 8.81 times 10 to the minus 15. It's not going to be exactly the same because we've rounded the coefficient portion of the math, but 7 is pretty close to 8.8 as far as this is concerned. The 10 to the minus 15 should be exactly the same. So if the two answers are really far apart, then you need to check your work to find your errors, because you've got an error in there somewhere. You should be able to do some estimation of number division. If you know your multiplication tables, and if you memorize these simple decimal equivalents to help you estimate division, then you should be able to estimate most calculations without a calculator. So you should know that 1 over 2 is 0.5, 1 over 3 is 0.33 repeating, 1 over 4 is 0.25, 1 over 5 is 0.20, 1 over 8 is 0.125. Note that if we go from 1 to 1/2 to 1/4 to 1/8, as the number in the denominator doubles, our result is half of the previous result. 0.5 is half of 1, 0.25 is half of 0.5, 0.125 is half of 0.25. Then we should have a few others that we know. 2/3, 2 over 3 is 0.67 or 0.66 repeating. 3 over 4 is 0.75. If you know these, then you should be able to estimate fairly closely just about all the calculations that we're going to end up doing. The method that you use to obtain your final answer should be slow and careful. An estimate is fairly quick, but if you want to get a value for your final answer, you want it to be slow and careful. You want to make sure that you're exactly right. So the method that you use to check your answer can be fast. This is our estimation. And it needs to use a different method. You don't want to do exactly the same method twice because you're going to get the same result, but you want to check to make sure that you're doing the calculation correctly. If you're doing the same calculation incorrectly both times, you're going to get the same incorrect result. So for some complex calculation using your calculator, work each calculation a second time using rounded numbers and or different steps or buttons in order to make sure that you are in fact getting the correct answer. So let's summarize. In your notebook, write a list of rules that we've covered in this section. Add these rules to your list of rules from previous sections. Then write and recite the entire list until you can write all of the rules from memory. And then, and only then, do the practice problems from the book. So you should follow the same procedure for summarizing each section after you've watched the video and read every single section. For every section, you need to do this procedure. Generally, I'm not going to mention this anymore, this summarizing, because it's going to be the same for every single section. It's up to you to remember to add new rules to your list from previous sections, memorize them, and then do the practice problems from the book. So that was estimating exponential calculations.